Okay, this is our INB video for today. It's on graphing rational functions sample number 2. So I just am going to go over 2 more this week, one today and one tomorrow. And they're slightly different than the ones before. Typically, they're horizontal asymptotes or having a hole or not having a hole. So on number 1, the first thing that you're always going to do is try to factor. And when I try to factor this one, just neither the numerator or denominator is factorable. So I'm just going to be carrying this function all the way through the whole entire problem. So the next thing I'm going to do is find my points of discontinuity. Those are the zeros of my denominator, and I only have one. So x can't equal 2. Now, this point of discontinuity can either be a vertical asymptote or a hole, but it can't be both. So the only way that I know which it is to see if that x minus 2 reduces with the numerator. And since it doesn't, I don't have a hole, and x equals 2 is a vertical asymptote. That can help me with the domain, which is everything but the point of discontinuity. Okay. The next thing I'm going to do is find my x-intercepts. Remember, with a fraction, if I'm looking at y equals, if the numerator is 0, then that outputs is 0 for y. So what I want to do is I want to say my numerator, this problem, whatever x value causes that 0 is going to output a y value of 0, and that's an x-intercept. So I'm going to take 4x plus 3, and I'm going to solve it for 0. And I get x is equal to negative 3. So if I plug a negative 3/4 into the numerator, that will cause that to be 0. 0 divided by anything is 0. So I know my x-intercept is at negative 4/3, 0. Okay, my y-intercept are going to be my constant terms of the function, because when I plug in 0, what I'm left with is my constants, and I can show that algebraically. So this is f of 0, and I can say 4 times 0 plus 3, 0 minus 2, so I end up with negative 3/2. Okay, next thing I'm going to come down to is describe the behavior of my vertical asymptote, my graph around my vertical asymptote. So I'm going to put 2 on the x-axis, and I'm going to pick a point really close to the right side of the vertical asymptote and one to the left side. So one to the right side would be a little bit bigger, one to the left would be a little bit smaller. And then what you're going to do is plug that into your equation. So I'm going to take 4x plus 3, and when I plug the 2.001 into this x minus 2, right, I'm going to strictly focus on the denominator. I get 0.001. That's the same as multiplying by 1,000. So when I plug my 2.001 up here, I'm just going to get some positive number. I really don't care what it is, because I'm dividing by a decimal that's 1,000, what turns into multiplying by 1,000. I know whatever positive number this is, when I multiply it by 1,000, it's going to be a really large positive output. So my graph is going up to the right. Now I'm going to do the same thing on the left side. And when I plug on the left side, let's look at the same fraction. When I plug in 1.999 and for x here, I get the same thing, but it's negative 0.001, which is the same because it's in the denominator as multiplying by 1,000. When I plug this up into the top, the 1.99 times 4 plus 3 is some positive number being multiplied by a negative 1,000. So I know the y output, right, is going to be some really big negative y value. So I know that it's going to be at the bottom of the vertical asymptote. Okay. And so the next thing I want to do is to determine end behavior. Remember, end behavior is the horizontal asymptote. And so I'm going to look at the degrees of the two polynomials, and they are equal. And when they're equal, they're the leading coefficient. So it's y equals, well, the leading terms are 4x and x. The leading coefficients is the number that is multiplying the leading terms variable. So 4 and 1, which is going to be y equals 4. And so now I want to know, does the function cross the horizontal asymptote? So to determine that, what you do is you're going to say, okay, if the horizontal asymptote happens at 4, I want to know, are there any x values that output the y value of 4? And if it does, then you know it crosses. So I'm going to write my reduced function, which this one didn't, so it's just the original. And then what I do is I'm going to solve for this equation and see, is there anywhere, is there an x such that my y is 4? And if so, that's going to be a point on the horizontal, so it would cross. So I'm going to multiply by my denominator. And I'm going to write this answer over here. So I'm going to distribute my 4. And I get 4x minus 8 is equal to 4x plus 3. Now I'm going to move my x's over, and I know right away they both cancel out. And so what happens is this equation is telling you there exists no x value for which my y value is 4. So this does not cross. Okay, the next I'm going to do is determine symmetry by plugging in f of negative x. So 4 times negative x plus 3 and negative x minus 2. Notice my top doesn't completely change, neither does my denominator. So, nor does it stay completely the same, so this would be no symmetry. And now I want to put in all of my information. So I have a y, a horizontal 1, 2, 3, 4. I had a vertical asymptote at 2. And my behavior at that asymptote, we decided was up on the right and going down to the left of the asymptote. I also know that I had a x-intercept at negative 4/3 and also had a y-intercept at negative 1.5. Oops. And let me see if there's anything else. Doesn't cross, no symmetry. And I think I'm ready to finish my graph. So I know it approaches here. And I know it's up here, so I know it's going to behave like this. And there's my graph. So hopefully that will help you. Maybe you get a little bit further if you didn't get the first two. Go back, watch this one. This should be very similar to the first two. Thanks.